In this video, we're going to go through Learning Target 4.3.2, which is finding area and perimeter of shapes with polynomial side lengths. So basically applying this idea of addition, subtraction, and multiplication of polynomials to a real world scenario where we're finding area and perimeter. So the first thing we want to do is kind of just remind ourselves about the general ideas of area and perimeter. And so the area is the space inside a shape. And we usually have very specific formulas for each type of area. So whatever shape you're doing, there's usually a formula for that kind. And so we have some pretty common shapes that we use. So for a rectangle or a square, we have the base times height or length times width, whichever you prefer. For a triangle, we have 1/2 base times height or base times height over 2. For a circle, we have area is pi r squared. And then perimeter is the distance on the outside and for perimeter, pretty much for all shapes, so I'll just draw a rectangle and a triangle again, but for any other shapes pretty much as well, you're just going to add up all the sides. So perimeter, you're just finding all the sides and adding them together. The only shape that has a very specific formula for the perimeter is a circle, which is the circumference formula, which is 2 pi r. So if you need to pause it to make sure you have that, please do so. Well, let's go through an example of each of the types of shapes we could see. So we're just going to find the area and perimeter of each of these. Sometimes you'll have a picture, sometimes you'll have a story problem, but the process is the same for each of these. You're going to use the formulas from above, but instead of just side lengths, you're going to have polynomials as your side lengths. And so for our rectangle, we have area is base times height. And I have my base here and my height here. And so I'm just going to fill those in inside parentheses. So my base is 3x minus 1, and my height is 7x squared minus 2x plus 10. And so because this is a little bit of a longer polynomial, I would use the box method for this to multiply. However, you could also use the distributive and distribute each of your terms. That's up to you which you prefer. But since I like the box, I'm going to draw a box, 3 columns and 2 rows. And I'm going to line up my polynomials to my box. And to get the inside of the box, remember we use the appropriate row and column, and we multiply the numbers out front and add the exponents. So before I make any mistakes, I'm just going to go in and draw my exponents of 1 so I don't forget that they're there. 7 times 3 gives me a 21, and then I have 2 x's and 1 x, so I get x to the third. Negative 2 times 3 gives me negative 6, and I have 1x and 1x to give me x squared. 10 times 3 gives me plus 30, and then I only have 1x, so I'm just going to bring that there. Down here, 7x squared and negative 1. Negative 1 is nice because 1 times anything is itself, so all I'm really doing is I'm changing the sign. So I'm going to have minus 7x squared plus 2x and minus 10. And so all I need to do is pull it out of the box in standard form order. So I have 21x to the third. These are like terms, so minus 7 minus 6 gives me negative 13x squared. And these are like terms to give me plus 32x and minus 10 at the end. So this is my area of my rectangle, and I can't do anything else to that, so that is my final answer for area. And then for perimeter, we're looking on the outsides. Like imagine we're building a fence, and you can see these two sides are not labeled. And in this case, we want to kind of mark the opposites because we know that they are equal. So I know these are the same as the opposite sides. And so you could either find your like terms here, which is what I like to do, or you could write it all out. I just think if you write this all out, it's just adding extra work. So what I do is I am going to add up all my sides, and I'm just going to go find my like terms up here, because all I'm doing is adding my like terms. So I have x squared, I have x's, and then I have constants. And so 7x squared plus 7x squared gives me 14x squared. Then I have minus 2x to give me minus 4. Plus 3 is negative 1, plus another 3 is positive 2x. So I did all four of those at once. And lastly, we have our constants. So minus 1 and minus 1 is minus 2. 10 and 10 is 20. 20 minus 2 gives me 18. You could also type those in a calculator as well. And that is my perimeter. So this first one is done. We found our area and our perimeter. Now this second one, this triangle here, for our area, we have 1/2 base times height. So we're basically doing the exact same thing we just did, except at the very end we are going to cut that in half, and this is our height and this is our base. So you can either do the distributive method or the box method, and I want you to try that on your own. So pause it, try it, and then come back to this and we'll see what you get for the area of the triangle. So if you use either the box method or the distributive method to distribute this and multiply these polynomials, this is what you should get. And with triangles, one of the most common mistakes is just forgetting to multiply by 1/2 at the end. So you're just going to go through and multiply everything by 1/2 or divide everything by 2. That's the exact same thing. And so we actually end up with our answer of 18x squared plus 6x minus 4. So now for the perimeter, we are going to use our knowledge that this is an equilateral triangle, and we are going to do all of the sides as the same. And the nice thing about if all the sides are the same, you can just take one of them and multiply by 3. It's the same thing as if you added them all up together. You could also find your like terms and add them up together to get the perimeter. So 3x plus 3x plus 3x gives you 9x, and negative 1, and negative 1 gives you minus 3. And that's the exact same thing as if you just did 3 times one of the sides, because that happens 3 times. So we get 9x minus 3 for our perimeter. Now we got one more left to do, which is our circle. And the circle doesn't give you much information, it just gives you R. because as we know, our area is pi r squared, and so that's all we need. You just need to know that squared means you need to do that thing twice. So we have pi out front. Pi is just a number, so we don't need to include that at all. But r squared means you're going to have 3x minus 1 times 3x minus 1. And again, you can do the distributive method or the box method, that's up to you. But go ahead and pause it and try to simplify that out and then come back to the video to see the answer. When you do your math, you should get 9x squared minus 6x plus 1. Just be really careful with negatives for both of these. And then you can just leave pi out front or put it at the end, or you can distribute it in and just leave it at the end of each thing. All of those are equally simple, so I'm just going to leave it like this as my answer. For perimeter, we do have to use a formula. Perimeter is 2 pi r. And so it's a little bit different. In this one, we took r, which was this polynomial, and squared it, so multiplied by itself. But this time we're just doing 2 times r. So I'm going to leave pi out in front, and then I'm going to actually multiply 2 times the radius. And so I have my pi out front, and I have 6x minus 2. The only reason I moved my pi to the front is so it kind of matched the format of the area. And again, you can leave it like this. You can put pi at the end. You can multiply pi into these. It's really up to you, but since this is already set up like that, I'm just going to leave it like that as my answer. So I know this video was a little bit longer than normal, but it's nice to go through one of each type so that you can see everything that you might run into, and these are the shapes that you might encounter in yours. So go ahead and do the independent practice that follows and check your work against the key.